So here, we're going to take a little brief digression from the way we've been going through our course so far. This fits really well with the fact that we've just finished up uh, our unit on trigonometry. And we're going to talk a bit about finding the areas of regular polygons, which will involve some trigonometry. Uh, this is a brief reminder. A regular polygon is equilateral, meaning all of our sides are congruent, and equiangular, meaning all of our angles are congruent. And those are both really important for us in how we find areas. Um, there's some vocabulary we have to go through that we haven't discussed with regular polygons so far. With a regular polygon, we have a center, which, like the center of a triangle, is, well, for lack of a better way of saying it, it's at the center. But we also have what's called a central angle. A central angle would be if I connect two consecutive vertices. Oh, that was terrible. The angle that forms here is called a central angle. And that's one of the angles that we actually want to know about. Well, here's the nice thing. Because it's regular, if I were to draw all of my central angles are all congruent. And to go all the way around is 360 degrees. So this is going to be equal to 360 over n. And that looks familiar because that's actually how we found each exterior angle in a regular polygon. Well, that's how we also find each central angle. So here we have 1, 2, 3, 4, 5 sides. So this is the same as 360 divided by 5, which tells us that our central angle is 70 degrees. 50 degrees, 72 degrees, and so on. Now, the one new piece of this that I do want to talk about is the way we find our area is we focus on one of the triangles that's made by drawing all of our central angles. Well, to find the area of a triangle, we do need to know the base will be one side of our polygon, but we also need to know the height. And the height of this triangle is an apothem. I know it looks like it should be pronounced apothem, but it is actually pronounced apothem with the stress on the first syllable, not the second. We typically use a lowercase a to represent the apothem, and that is something that we'll need to find, which is where trigonometry comes in. But the apothem is really nice because since we are dealing with regular polygons, each of these blue lines is congruent to my triangle's isosceles. That means that when I draw an apothem, it bisects my central angle. If my whole central angle was 72 degrees, each of these is 36 degrees. But it also then means it has to bisect the side. And so by doing this, we take advantage of this and trigonometry to be able to find lengths of sides, lengths of the apothem. And this is all very useful for us because to find the area of it's going to be 1/2 times the apothem times the perimeter of the polygon. Because by finding the perimeter, that actually will allow us to say we want all of these triangles. So in terms of symbols, it's 1/2 A capital P. Where A is the apothem, P is the perimeter of the polygon. So let's go to an example here. So here, cover of a hot tub is a regular pentagon. We're told the side length is 0.5 feet. We are told that the apothem is 1.1 feet. Well, the perimeter is to be number of sides times the length of one side because it's equilateral. So 5 times 2.5 is 12.5. We're told the apothem 7. So my is going to be the apple times the perimeter. And as I'm getting that figured out here, that's going to be 10.625. And its area where distance was measured squared. Now, we're not usually fortunate enough that we are told both a side length and the apothem length. Normally, we're going to have to figure out one or the other, or even both of those. So, for example, here we have a regular octagon, 8 sides, where we're told the apothem. In the drawing, this is for apothem. So we know that the apothem is 8. But we need to find the perimeter. To find the perimeter, we need to find the side. So the way we do this is we actually go ahead and draw it in so that we can see the side triangle. So if I kind of draw this separately, there's my side, here's the apothem that we know is 8. For a central angle, that's going to be 360 divided by the number of sides, which is 8. So my central angle is going to be 45 degrees. But the apothem cuts that in half. So I have 22.5 degrees for each of these angles. If it helps, we can draw it separately like this as well. And here's 8. This is 22.5 degrees. Now, what I need to find the perimeter is I need the length of one whole side. Well, if I look at half of the triangle made by central angle, this is half of the side. So if I call this x, and I want to find x, well, if I focus on the 22.5 degrees, I could use tangent. So the tangent of 22.5 degrees would equal opposite over adjacent. So x is going to equal 8 times whatever the tangent of 22.5 degrees is. So x is going to be 8 times the tangent of 22.5. Thank goodness for a calculator for this, which will give me 3.314. But that's half of the side. So one side is double that. So one side is going to be 6.627. And then my perimeter is going to be 8 times the length of one side, because I have 8 of those sides, which is 53.019. So now I know the apothem was 8. I know the perimeter. I can find area. So 1/2 times the apothem times the perimeter. And so I get that my area is going to be 212.077. And we're measuring length in inches, but my area is in square inches. And here, our area.